Welcome back, everyone, for a continuation of our panel on commercial space transportation. We've spent the previous hour hearing some perspectives from a commercial launch provider and the activities on the Virgin Group. Heard a really fascinating presentation from Oscar on the future of the kinds of vehicles and operations that we can anticipate, and Nico tying it in with the air navigation service provider's perspective on the operational considerations to accommodate these new operations, these new vehicles. Now we're going to be able to turn back to another industry innovator, and we're very, very pleased and excited to have Leon Troves from Worldview Corporation with us today. Leon is the licensing lead for the Voyager suborbital flight vehicle, a balloon-based vehicle ascending to the stratosphere. Leon also works with the mission control team for satellites. For satellites uncovered for long-duration missions as a flight controller. So I really mangled that, Leon, and I apologize because I walked up here without my glasses, in full disclosure. With no further yammering on my part, Leon, please.
Well, good afternoon, and thank you, Dee, and apologies are probably mine because of the horrendous handwriting. So, but my name's Leon Troves, and I work for Worldview, and in particular Tabor McCallum, our Chief Technology Officer, who was going to present today, but is due to operational requirements is in Tucson conducting some testing. But I'd like to start with a little bit of an overview about what we do at Worldview. As Dee mentioned, work on not just the licensing side of things, progressing the Part 400 license under the AST's regime, but also with our uncrewed applications, our Stratolite, and working in mission control there as a flight controller, flight coordinator, working very closely with a flight director and mission planners to work through both mission design and then in flight. And that's mainly to ensure safe coordination of airspace. So begin with, and yesterday we spoke about the Stratolite, and today this is more about the human experience because it falls under the AST part of regulation. So to understand to Worldview is to understand the StratX program, which was stratospheric exploration. Began several years ago and with Alan Eustace from Google, Tabor McCallum, my boss, got together and over a program of 3 flights took Alan to the stratosphere. So that being a fantastic demonstration of the art of the possible, the question was, well, how do we bring this to others and in perhaps a more leisurely environment and something that doesn't quite involve a spacesuit? So you just play this. Right. This is a short video about that experience with StratX. New Mexico. So that's what has, you know, that's history. That's been achieved. Alan went to 136,400 feet, set several records, and I've forgotten what the next slide is, but there we go. Okay. So there you go. There's a few of the records that were achieved, and that foundational team that conducted the StratX program then went on to build Worldview as it is today, and with the aim, much like Virgin, of democratizing access to space. The Voyager program was born, which was to take 6 people to 100,000 feet, say afloat, observing the atmosphere below and above for a couple of hours, and then descend safely under parafoil. And that's a conceptual view of that concept of operations there. And this video, I think, shows what we intend it to look like for the passenger. So you can see it's a little bit more comfortable, but no less exciting than Alan's journey. So that's where we're going with human suborbital spaceflight, and that's how we see it occurring, evolving. But as we spoke yesterday about the evolution of air traffic management above flight level 600, that's going to affect us as well. So with safety being the only true metric, and that's where we should start. We've heard already, and yesterday and again today with the UTM panels, that there seems to be still a lot of discussion about which way technology and regulations will go. So no real set consensus other than something has to evolve. And of course, regarding upper airspace, is yet to be resolved the issue of state sovereignty. Further complicating that, the new entrants, winged rockets, hybrid vehicles, space launch systems, space re-entry systems, etc. So there is these definitions are evolving and posing more challenges for not just industry but for regulators. Some of those points that we at Worldview feel strongly about that should be looked at is, again, safety driven, but let's look at the likelihood of conjunction or collision, the use of real, accurate and timely information and it being shared in an open collaborative way, the ability to extend to air navigation service providers the information they need and the context they need, contacts and context, regarding non-cooperative vehicles or debris as they come through into the lower altitudes, as well as and of course at all times prioritizing the safety of the uninvolved third party, the public. Some systems we might want to look at and evolve include building on an existing system to assure this rapid and effective implementation without necessarily invoking a whole swath of new regulation. I think that's consistent what we've heard yesterday and again today, as light a touch as possible with industry providing the direction and the emphasis, but certainly taking advantage of regulators' vast level of experience in this. So one idea, one option, and thank you, Nico, for introducing, I guess, some of these concepts perhaps in a bit of a different way, but perhaps we could introduce an existing space situational awareness solution and bring it down to these lower flight levels. Again, safety-driven, operations-driven, based on accurate and timely information sharing, and mitigation not only of conjunction probability, but other issues which may pose problems such as radio frequency interference. So that brings me to the Space Data Association, an operational body which has been around for some time now and is formed by the large civil and commercial satellite operators, with military satellite operators involved as well. It is a body that is run by industry, that is not a lobbyist, not a lobby group, but is very much focused on safe operations. And they have shown expressed an interest in studying the lower altitudes, suborbital, and seeing how their model may be applied. Fortunately, they have great experience in deconflicting orbital movements, and they use a very powerful set of tools driven by AGI, which some of you will be aware of. For applications in airspace, it provides some tremendous modeling. But that's one tool. This is an idea of creating that situational awareness based on real and accurate and timely information. And the idea of a space data center, which already exists, and again, this is just an idea to provoke some thoughts and some argument even, but such a center that already exists may be able to provide that coordinating activity back to air navigation service providers. So on that, some of those ideas are perhaps a little bit controversial, but the heart of it is that information needs to be shared, it needs to be a collaborative solution, and we need to get there sooner rather than later. And I'd just like to thank the panel and ICAO for having us here this week, and look forward to your questions. Thank you.
Our next panelist is Dr. Li Hao, who works as Deputy Director of the National Research Center at the Stanford, and Director of Aviation Law and Standards, and Director of the Institute of Aviation Law and Standards at Beijing University. Dr. Li Hao's been on several panels, both today and yesterday, so some of you all may be aware of his background. But I have the good fortune of working with him on the Space Learning Group, and so it's an exciting opportunity for me to hear some other perspectives other than you and I figuring out what the next steps are for the group. Dr. Li Hao.
Thank you. Well, today we are providing one more new concept. We have talked about the EUS. Today we will talk about a new aerospace law. So situation awareness. In the space now we have, Nico have probably updated data. Now we have more than 1,300 satellites operating in the space. And the GEO is almost full, the C spectrum is full, Q is almost. And the Earth, the planet, is surrounded by millions of debris, and it is also increasing. The air traffic flow will be doubled by 2034. So we need new operation, and we have a new operation, and we need to find a way how to make the new operation possible. The new operations, as we have discussed, we have UAS, we have near space operation, the balloons, the Facebook. This is a dreamer. This is part of my homework. This is a dreamer of Beihang University team, and some other new operations. This picture is drafted by our French colleagues. In the aerospace industry, no regulation, no business, but the law, we have air law, we have space law. But when we use air law and space law to meet the new operation, we are facing the following challenge, as we have discussed on the first day, that is, which law applicable? This is a question that has been discussed by our academia for several decades already, air law or space law. And also, not clear answer that whether the operator could share the freedom of flight and the deployment of their platform or their craft over the near space or even upper level above the undernice country, and whether they need licensing from the undernice country if they are going to providing even free service like the internet service will be provided by Facebook, by Google. National security concern, the general public's privacy concern, and the liability to the aircraft flying in the airspace, the liability to the people and the property on the ground, and also the liability to the service receiver. Because we only have traditional air and space law, it is unbalanced, so it is not quite in favor of innovation and the development of the new operation. We have to think out of the box. Well, the history is always the master or the teacher of the future. So as I have showed presented the picture before, in the air law, when we have when we start the manned aviation, the balloons, the aeroplanes, we don't have ICAO and no matter domestic or international air law. When Sputnik was launched, we don't have UN-WUSA and also the space treaties. The world, the human, and the society is evolving, no matter in this way or another way. And the law should also be evolved. And as I had mentioned, we have a teacher, and we also, for the air and space law, we also have a mother, that is a law of the sea. In the maritime law or the law of the sea, we started from territory law and the high sea. But now, with the development, we have new legal regime in the law of the sea. We have two parts have been involved to have seven different regimes. We have economic, we have EEZ, we have a continental shelf, we have some other concept and rules. And if you may spend some time to read one of the jurisprudence that in New Haven School of Law, you may find the law, even the international law, is drafted by the community to seek the peace, good order, development, and human dignity. And it could be and should be reformed or changed by the community accordingly if the community thinks that is necessary. So the law is not, can be changed. We cannot say, oh, this is a law, you cannot change it anymore. Even the convention, we could change it. And that is why, based on the jurisprudence, we introduced the EUS for the utilization and good governance of the near space to balance the safety, security, and sovereignty concern, and also the development of the new operation. So EUS balanced the interest of different parties and provide a minimum level of certainty. The future, we talk about the upper level operation, and today in the afternoon we also talk about space transportation. The future is coming. We have so many industry colleagues, they have introduced their operation, their plan in the coming years. So we have to, now it's time, especially for the regulators, to rethink, to invent, to recreate our legal system. So at least, as Nico and some other colleagues had discussed, in the traffic management, they are evolving. We are upgrading our ATM system. We are thinking of space traffic management. In the lower airspace, we have a UTM. The law is always lagging behind, but we need to start. So it's time to have a new innovative aerospace law, not just air law, not just a space law. Two separated systems. We need to think about to integrate the air and the space law. The good news is that under the leadership of Dee in the space learning group, we have a subgroup, that is the legal subgroup. Please, if you have a strong interest, come and join through different channels to the space learning group, work together to set up a new aerospace legal regime. So to join, be the members, and be the founders of a new era of aerospace law. Thank you.
Thank you, Li Hao. So we've heard from a couple of the commercial entities that are looking at new ways to take people into space. We've heard from an air navigation service provider perspective. We've heard, again, about the operations of these new vehicles. We thought it would be a really interesting way to underscore that while all of the potential exists to change, commercial aviation, commercial space as we know it today, that there is always going to be a strong tie into the harmony between the commercial space community and the commercial aviation community. So we've invited David Bowen from the SESAR joint undertaking to join our panel today. David is the chief of the ATM unit, responsible for the technical and operational content of SESAR, including the long-term exploratory research program. David?
Thank you. Good afternoon, ladies and gentlemen. I'm going to talk a little bit about some of the drivers for change for the future ATM system. It'll touch on the space transport that we've heard about, but I'm talking more generally about the way things are going to evolve and the way the system needs to adapt to changes when they come, be they driven from the space segment or the information technology segment or whatever. We know there are going to be some major changes, and we know that change is going to accelerate. The slow evolution of the air traffic management system that we've lived with for the past 5 decades is not going to take us further into the future. The increasing world population means there's a greater demand for travel, including space tourism, as we've heard from some of the speakers on the panel before me. There's also a pace of change. The technology is coming, driving forward this pace of change in a way that aviation and ATM has never seen before. The experience of travel itself is going to change. We're going to have less of a distinction between the process of travelling and the process of arriving. The travelling itself actually will become part of the experience. I think we've seen some examples of that. But some of this is enabled by this notion of connectivity. We have this ever-increasing opportunity to be connected wherever we are, and this brings through into the transport system as well. And automation, of course, will also drive that change. Brings a new way of working to the wider world, but particularly into ATM. And the roles of the human in the ATM system are going to change, supported by automation, but even taken over by automation, depending on how that evolution happens.
There's going to be new players in the aviation and ATM industry as well. It's a very traditional closed industry for many, many years, but the tech companies, the innovative players are coming, and they're going to be part of the ecosystem that we need to start to design. So what is changing? Well, today we have an environment which is very controlled, very self-contained, with a relatively small number of aircraft. Thousands, you may not consider that small, but ultimately it's a controlled and well-contained system. We're looking forward to a future, this digital aviation infrastructure, with many different types of vehicles. Of course, we've heard all about drones and the potential for so many different, hundreds of thousands of vehicles of such different types, with radically different performance types. And all this will change the way we need to manage them. The traditional methods of providing air traffic control and air traffic management are just not going to work in this new environment. The pace of change, the automation, the need to adapt, that's critical for the ATM system to move forward. We're going to have different demands on the airspace, as we said before, different ways of attracting customers, different offerings, different business models. All of this, again, drives the pace of change. We look back on the low-cost evolution, the low-cost airline evolution, which was quite dramatic to the airline industry at the time. But this is going to be trivial compared to what we're facing in the coming years, the changes that are going to come into the aviation system. The ATM system has to enable this change and not be a constraint, and that's our challenge here in the frame of ICAO. We need to be part of an integrated transport service that actually delivers to people's needs. So we have challenges and we have opportunities for this aviation ecosystem. We're already changing the dynamic of ATM. We already adopted the principles of this digitalization, connectivity, automation. We have the notion of system-wide information management that's progressively being implemented. We have advanced controller tools. But the pace of change today in ATM will not meet the future needs. These new players are bringing in innovation in a much more dramatic way, and we need to learn how to adapt and adopt those changes into the ATM system. Airspace itself, we need to understand how we share it with all the new vehicle types, the new types of aviation, the drones, the space transport. The way we manage that use of the airspace is critical. The level of automation, we're looking at a system of such complexity, it becomes difficult to imagine it being managed in a manual way, even with automation support. So do we need to look at an autonomous ATM system, looking at things like artificial intelligence as a support to the way we manage this traffic? These are all challenges that we need to look at in ATM. So much of what we're looking to in the future is dependent on this issue of data sharing. We heard before about the need for collaboration between the different sectors. Within ATM already, we have this great challenge of sharing information between the stakeholders, ensuring that we have the most coherent and effective decision making. And that expands as the stakeholders grow, as the new vehicle types, the new types of use grow, that need to share the information grows. And that brings with it itself huge challenges, because information sharing is the backbone to all of this change. But the information sharing comes with the challenge, particularly of cybersecurity. Everyone's aware of cybersecurity as a threat in the wider world. But when we start to build a potentially autonomous or highly automated system that is really safety critical in the way it will be, and that system is totally dependent on information sharing, system-to-system interfaces, we have a huge potential attack surface in terms of cyber. Therefore, it's a real challenge for us to understand what that challenge is, what the threat is, and how to mitigate against it through both technical means and operational means. Aviation infrastructure also needs to adapt. We have a very traditional way of doing things for the past decades of building a piece of hardware, and that piece of hardware providing a capability in order to manage the traffic. But that's going to change. We're going to move to a service-based infrastructure. Satellites offer us opportunities in terms of infrastructure in the space segment as well, that gives us this idea of an integrated communication, navigation, surveillance capability that can enable all of these changes and all of these capabilities that we need in the future. So, just to come back on where we are, we've got a huge need for change within ATM. Not just changing the system, but changing the way we evolve the system. It's going to be driven by these principles of digitalization through connectivity, information sharing, and automation, even all the way through to autonomy, with artificial intelligence being inherent in the system. But safety, security, and resilience stay at the center of what we need to do. There are new threats, new challenges, new things we need to think about because of the way the system evolves. But we have to keep these issues right at the heart of it. We need to move away from this notion of physical assets, and we need to look at transport as a whole as a service. Transport as a whole as a service to the passenger, and a transport system that services the passenger through the way we provide transport. I think there are huge challenges ahead for us as an ATM community. Particularly here in ICAO, I think we really need to grasp this new way of thinking, this new way of working, that we can actually effectively enable all these exciting ideas for the future, all this interesting stuff that we've heard from the other panellists. Unless there's aviation, we adapt and understand how to manage it, we'll be overtaken and be obsolete. So it's time for us to look for the future and make the changes. Thank you very much.
David, thank you very, very much. So, I'm thinking that for many of you, after hearing the discussions by some of these panelists, are going to get on your commercial flight home to wherever you go and think, this may be a little bit boring after some of the concepts that have been talked about today. But the reality is, you know, certainly from my perspective, and I think it's shared by many, commercial space is at a juncture that commercial aviation was many years ago. And, you know, the good news is that we can learn from the lessons of the aviation community and adapt some of those things to this industry as it grows and hopefully thrives. So I thought I would come back to our panelists and gauge their thoughts on some of the things that they highlighted. And Rich, if I could begin with you. You know, it's always thrilling when we get news of some of the test results from the various companies, and certainly the Virgin efforts, no exception. But I think it's also fair to say that space tourism is viewed as a rich man's, or should I say, a rich woman's sport. And if indeed the idea is to democratize space travel, what do you think? I mean, what do you think the future of that really looks like?
I think that... Is that on?
Yep. Red.
I think that with any new technology, you will always have a transition period. Just if we think back a few decades ago, I mean, owning a personal computer seemed like a luxury that was unnecessary. And now, I mean, I think each of us probably has multiple computers in our lives, our iPads and phones and our home computers and our work computers. And I think the same with the technologies that we're talking about now. So we talk about suborbital, and then that merges technologically with a discussion about can you do point-to-point on the Earth's surface using space-like concepts for regular travel. And I think that that's the arc and the trajectory that we hope that we're on. So yes, there will, early on it is expensive. It is certainly expensive to fly. I think, you know, where our prices have been out there, it's $250,000 for a seat to fly, and I know that people have spent millions of dollars to go to the space station and to be astronauts that have spent a significant amount of time in space. But I think what we are seeing is that as those technologies become more understood, as the vehicles that we're flying now, which really are really rudimentary compared to where we will be in a generation. Just like the first flight at Kitty Hawk looks almost comical to us now as we think about aviation. So as we fast forward and the technologies mature and become more sophisticated, and they will, I think, become much, much more affordable. So this is the first step, and you have to start somewhere. So I think that within a very short period of time, I think we'll see the transitions that lead to truly opening space and hopefully point-to-point travel on the Earth to anyone at a reasonable cost.
No, thank you, Rich. I mean, I think it's very clear, certainly from the interest that people have expressed to your company as well as the others. There's certainly a huge desire, cost notwithstanding, and the fact that, again, these folks are going aboard the spacecraft under an informed consent regime with absolutely no guarantees. But they're obviously, Leon, if I could maybe ask you to share your thoughts on the same topic.
Thanks. I think for worldview, where of course we'd love to take as many people as we can to have that overview experience, and that's something that astronauts describe as being very important. You probably heard it before, but from space or near space, you don't see borders. And one comes back with a view of very much based on collaboration and problem solving, rather than a dogmatic approach to observance of rules. So in that way, it would be great to get as many people as we can to experience that, to enhance their, I guess, the art of the possible, and have them really think about how they can really contribute to the environment. But if I may, I also like to talk about one of the other applications, and not just for those who are wealthy, but we see considerable application for scientific investigation, and using the platform as a suborbital laboratory of sorts, for many hours. PIs can conduct their experiments and then bring them back. So we think there's a number of ways that the community can benefit even if they can't fly.
Leon, thank you. Let me ask the audience. Feel free to raise your hand if you have a question that you'd like to bring forward, whether on this topic or anything as we go through. Nico, I thought I would ask you your thoughts on reconciliation, and specifically what I'm thinking about is reconciling, if you will, the different approaches to risk tolerance between aviation and space. And as an example, some of the work that we're doing in conjunction with our colleagues in air traffic at the FAA is what we call an initiative acceptable level of risk, which is not lowering a safety bar, but it's trying to bridge a divide between different philosophies. Your thoughts from a CANSO perspective?
Thank you, I think if you look at the risk matrix at the moment for space operations, it's close to 1 out of 10, or between 1 out of 10 and 1 out of 100 that has a problem. That is not acceptable, of course, in commercial aviation. And we understand that it is like that. I think in commercial aviation, when we started, we also had a lot of accidents and things. The only difference now is that it is operating in a very busy environment where they should not be interacting with commercial aviation and not lowering the safety standard of commercial aviation. And that's why the collaboration and cooperation and integration or separation is so important, that we keep the aviation environment that we have now as safe as it is, or as we're trying to get it even safer, and then integrate this new technology that has a risk that is bigger than in a commercial aviation, keeping separated from the safety standards that we have in commercial aviation at the moment.
Thank you, Nico. David, did you have any thoughts on that?
I think that I think what Nico said is absolutely true. What we need to do is ensure that we maintain the safety perspective from the aviation side of things, whilst enabling as much as we can the space operations. I think that there's going to be many different ways to do that, but I think it's absolutely clear that it wouldn't be acceptable to start degrading the safety of the aviation system. But I think there's definitely mechanisms that can achieve that, and I think you come back to this collaboration, cooperation, sharing of information. Again, I think it was raised earlier, this issue of, do you need to close the airspace in a large area for 3 hours or whatever? And of course that has not so much a safety impact, but an economic impact on the airline business, for example. And I think that's where we need to manage the interface, that we can find something that is maintaining the safety, of course, but also operationally acceptable in terms of the impact it has on commercial aviation operations, and that's the challenge.
Thank you. It struck me also as we were talking about certainly not doing anything to the detriment of one operational environment at the cost of another. I think what we're really having to think through is public perception. So when even I'm very sensitive when I use the term acceptable level of risk, because to the wrong audience, the challenge becomes, what exactly is your definition of acceptable? And when I think about public perception and how we message the advances of this industry, I think there is really a lot of discussion to be had, because like aviation, the space industry is learning by its mistakes. And I'm going to ask the panel to kind of weigh in on this issue of public perception and how do we message what we're doing and how we do it. So the instance I was thinking about in the U.S. is a spaceport or a small community that determined that it wanted to take a relatively small feeder airport near a major international airport and turn it into a spaceport. And they came upon that idea because they thought it was a great economic incentive for the county and for the community. And promptly set about talking about becoming a spaceport. Well, in fact, the citizens in that area started thinking big Falcon Heavy rockets taking off from their backyard. The airlines thought about big heavy rockets taking off near the end of their runways where they had flight operations. So we quickly found out, that there was a big lesson there in terms of messaging what it is that we're doing and why we're doing. And, I just use that. I think there are hundreds of examples. Rich, I'm sure you all have encountered them, and Oscar. Maybe give some thoughts on this issue of managing public perceptions, managing expectations, getting our message out in a proactive way. Whoever.
Thanks. I think a common misconception could be the distinction between commercial space flight for research or technology development versus commercial space flight for commerce or trade, the movement of goods or people for a purpose. I think we should emphasize that distinction, and it's created some misunderstanding. And obviously aviation, 3 billion people flew this year in the air transportation system. It's logical that people compare flying in the air and space. So we need to stress that distinction. What is transportation, commercial transportation, versus what is experimentation or technological development?
Thank you, Oscar. Rich?
Yeah, I think we have a challenge, which is explaining these new technologies and the risks that they have, because I think people do tend to look at this either through the lens of a science fiction episode or to lump everything all together into one. And as I think I tried to show in my slides with respect to the White Knight and the spaceship for our suborbital mission, well, first of all, very little risk to anyone not actually participating in the flight itself, and very little burden on the airspace. And I think that what you have to do is look at each proposal separately and to understand, okay, what is the risk or the threat here. And also, it's the role of the government is, and our ability to tell people what they can and cannot do. I mean, people drive motorcycles, even though it is clearly obvious from the statistics that motorcycles are more dangerous than driving a car. Private planes are more dangerous than flying in a commercial jetliner. So, I mean, we have all these things where we have data, which as humans we know. And then the question is, what is the role of the state and the role of the individual in assessing that risk? It is probably not a wise decision to climb a mountain. Particularly a mountain as challenging as Mount Everest. There are lots of people. So I think as we look at these issues, there are multiple, first of all, there's a very basic educational task which says we need to understand the difference between a large rocket and a very small concept like we're talking about. Just simply the energy you're dealing with is fundamentally different. And then I think at the other end, you can have a legitimate discussion, and different countries will come to different conclusions about how much choice does the individual have compared to the society's right to monitor dangerous activities. And that's something where in the United States, we reached one decision, which was, okay, there's an informed consent regime. People should understand what they're doing, that they're not getting on a commercial airliner. Other countries may decide to go in different directions. I know that a bunch of countries are looking, as your chart showed, a number of countries are looking at having spaceports, and therefore everywhere a country is talking about a spaceport, they're also going to have to ask the question of, well, how does that integrate with our airspace and also our concept of sovereignty and the concept of individual choice. So these are actually fairly complicated things that every country is going to have to decide on their own.
No, thank you. Nico.
Thank you, Dean. I think it's a very interesting question, but I think we have to look at it on two ways. The discussion that we just had about people knowing that they go into a dangerous operation. And I think that level of acceptance of a safety risk is there with people who go into it. The acceptable level of safety in commercial aviation is that the public want 100% safety. They don't want anything to happen when they fly. They expect nothing to happen to them when they fly. So when we have these operations going through that commercial aviation system, I think and let's hope it doesn't happen, but if something happens, a collision with a commercial aircraft, it could either kill space operations completely, or UTM, or whatever operations there is, because the people, the public, the passengers don't accept it. They want the 100% safety on the current aviation system. And therefore the collaboration, separation that we talked about is so important. We have to maintain the safety of the current aviation system. Because if they stand together and the people get the notion that having the new systems inside this system will decrease their safety, my vision is that the passengers don't accept it, at least not for a decade.
Thank you. Lee Hao, did you have anything to add to this particular point?
Well, I treat this as, especially for the regulation part, I treat this as a public decision-making procedure. So you have to think about the following factors. First, the actors. Second, the goals of different stakeholders. Third, the environmental or predisposal conditions, and the probable course of action, and last, the consequence that may happen. So it is a procedure, and since the factors are different, the result in different countries may be different. So quite a lot of colleagues use the word of acceptable, or we may think about a reasonable. but no matter acceptable or reasonable, they don't have a clear quantitative answer. So let the public work together to decide what is acceptable, what is reasonable.
Thank you. Rich?
On one comment, just one comment about injuries to the uninvolved public. I think that we are at a point where we're likely to see much more activity going forward than we have seen in the past. But it's useful to note that in a half a century of space travel, I think the only, at least to my knowledge, I think the only thing that I know of an injury to an uninvolved public from space travel was, I think a fairing from a European rocket hit a cow once. And that's in a half century. So I think so far, we're pretty good at separating space activities from air activities. Now, granted, we are talking about an accelerating pace of space activities, so we have to be very, very careful. And I agree with you. I fly an awful lot. I have an expectation that it's safe. But I think we also need to just look at the facts, which are that we don't have any example of uninvolved public being injured. Well, actually, well, never mind. I can think of one example, but I don't want to go there because it's political. But let me just stop with that.
You all can tell that Rich is from Washington, right? Nancy?
I'd love to get in on this discussion. So, Nico, you know I love you, right? Now I'm going to have to just bust out the hammer. So, look, I don't think any of the new entrants are talking about in any way degrading safety. I've not heard anybody say that. So I don't think that's on anybody's lips or anybody's mind. I think they're trying very hard to be good aviation citizens. But I think what we, as some of the elders, have to think about is that we have to change the way that we think. For example, if we go back to ACAS or TCAS, nobody wanted to accept that the machine could do it better than the pilot or the controller. But in fact, we accepted that, and we've been safer for it. So I think we have to accept that the new technology is going to enable us to put more air things, whatever you call them, in the sky and do it in a safer way. And it is a different way of thinking. It is hard to begin to think about more reliance on the machine, but the human will always be in the loop. So I think at least for me, having left the traditional aviation community after many years and going to work with these new crazy guys, they get it. And I've had to sometimes go, whoa, you're going to do what and when? And in fact, 1,500 flights later, there's been no degradation in safety. So I sincerely think we have to just continue to readjust our thinking and continue to get a little more educated on what's happening and what they're actually putting into the system as safeguards that are just different than what we think today. So I think it's incumbent on all of us to just try to learn more and think differently. And for CANSO, I think CANSO has to step up and say, how are we going to integrate this? Because the other option isn't there. I mean, we put them out of business. The ones that aren't going to lean forward and open up and find new ways of providing air traffic control service are going to go out of business.
Nico's rebuttal.
No, thank you, Nancy. I fully agree with you. And we want to integrate them. We have to integrate them. It's the future. But we also have to be careful that we do it right. And I think everybody here is doing it right at the moment. But as it grows, we see even more people trying to get into it. It's a business. So we have to have the regulation, the coordination, the systems ready. And we have to start working on it. And that's the message that I want to bring. And perhaps also we should start now educating the public, the general public, what is coming. And that it's not science fiction. And it's not the Millennium Falcon. No, it is coming. It's there. And tell them about the safety. Educate them. And not just at issues like this where the aviation community is, but out there. And then let it roll out in a way that we want to roll it out. And that we all have to pursue and assist that it will happen. Because it has to happen. Thank you for your message.
I think And I'd like to pick up on both, Nancy, on your comments, and Nico, yours as well, because I think they're absolutely relevant and absolutely in the spirit of what we're talking about. So, it goes in my mind to comments made earlier about learning, learning from the different communities, learning from each other. Because, again, commercial aviation has made advances over the last 50 years that, I would say 50 years forward we'll be having such a different conversation about space travel and things. But I was also thinking, David, Leon, about your discussion about definitions and how ICAO has definitions that regulate, and it has struck me for a long time, having come into the commercial space community after a lengthy career in commercial aviation, and how the two sides use completely different words. I mean, I heard Rich talk about an apogee, and I was wondering about how many people in the audience were familiar with the term, and again, the things that we take for granted in the environments that we're so used to, and then I think about, communication is so fundamental to any form of advancement, whether it's society or industry or anything, and is in your mind, I mean, you raised it as a point, and it is valid, but in your mind is definitions, is learning the language between the two organizations in order to, or if three organizations, in order to, enable that really sustained growth, is that one of the key issues we're really talking about?
Yes. So, as we were, hearing, and if I can maybe rewind a little, back to, expectation management, and then communication. So, for Worldview, we're located right next to Tucson International Airport. Okay, and that has its challenges. And of course, initially there was quite a hesitation from both the airlines and the tower. But I tell you what, once you go on a tower tour, you tell these guys, this is my concept of operations, this is what it's going to look like out there, and then we're going to stand and we're going to wait for you to tell us when to go, and the thing's not going to, it's a lift gas, and it's very sort of leisurely or controlled, 1,000 feet per minute ascent, and then you show them the flight safety analysis that we do for the weeks ahead of the day of operations, and then the day of operations, and you show them the tens of thousands of simulations of that climb out path. That's when they start to, okay, I'm starting to get what it really is, and you're breaking down what their perceptions are, and starting to, I guess, really bring them on, and sometimes as fans. But in terms of definitions of vehicles, I think that's going to continue to be an issue as there seems to be a new vehicle every day and a new way to launch it. But I think definitely lessons from space in terms of the nature of suborbital mechanics, at least. I think educating controllers about what that actually means. The hypersonic re-entry, for example. And does it come down under a round parachute, or as we do under a parafoil, and then we're steered onto a landing zone? So yes, there's plenty of challenge about not only definition but in communication and outreach. But let's start it. We can't ignore it. Let's talk about it. And anyone who wants to come, and talk to me about our operations, please do. And especially to controllers. if that's something you're concerned about, the characteristic of the vehicle, etc. So the more we can do that as an industry through demonstrations or technical interchange meetings, presentations like today, or us just being out there and talking about it, the better. And the more questions you ask, the better. So a long way of sort of getting to that point.
That's great. Oscar.
Yes, I couldn't agree more. In the context of ICAO and civil aviation authorities of member states worldwide, perhaps the best way to avoid misconceptions and to clarify on investments and projects is for the civil aviation authorities to listen to industry in their own country to see what is it they need and they're doing. Because to create a prescriptive reaction to some technological breakthroughs that happen in a couple of countries around the world could be something counterproductive. So what seems to work for us in the US is that the industry who is actually flying and testing and experimenting with new technologies are capable of telling the civil aviation authority, the FAA, what is it they need, and with what standards and with what levels of safety and reliability. And then if that dialogue starts from the ground up, from the real markets, the real people who need the capability for tourism, point-to-point, whatever, and then bubbles up to the regulator. But the danger is if it happens the other way around, where conceptions or ideas that come from outside of reality or practical knowledge start regulating something that hasn't even been born yet. So that's, I think, the flow from industry to regulations and the listening of the regulator is very important.
Rich.
If I could change the topic just for a little bit. I had a question.
That depends.
I had a question for David
Okay.
about what he was talking about in terms of the evolution of the air traffic management system, which really, it goes to the core of how all of these things are happening at the same time. And I guess my question was, in your remarks, it sounded like you were looking to the intelligence to be concentrated at the core. But what we're seeing in the automobile industry is actually the reverse. That the intelligence is going out to the individual vehicle, which has to be able to be capable enough to manage in a completely chaotic world with human drivers who are absolutely unpredictable. And so it's almost like there is no central coordination node for terrestrial transportation, and every unit has to be an autonomous functioning entity. To what extent can we expect the future, particularly when we move to a future where artificial intelligence is playing a greater role in decision making? How much decision making authority can you actually push to the airplane itself?
It's a good question, and it's somewhere where we always face a balance in the traditional ATM system between a controlled and predictable total system and a system that allows flexibility at the level of the individual vehicle. I think I'll come back to really answer the question, but if I deviate slightly into the emerging world of drones that we face today, it's very clear that the controlled approach that we have in ATM is not going to be able to be applied to the drones world in the same way. You're not going to be able to have this central view of the movement of all of these hundreds of thousands of vehicles that we perhaps aim to have for commercial aircraft, traditional aviation. And so the world of drones is definitely an opportunity for us to learn about the extent to which the system can benefit from autonomy at the level of the vehicle and how that fits in with a managed system. So I think we will learn as an aviation community a huge amount probably in the next 5 or 10 years from the work we're going to do in drones as we start to put autonomy and artificial intelligence both into the system and into the individual vehicles. I think you raised an important point with regard to the autonomous road vehicles in terms of the chaotic environment in which they have to operate, and that's very clear. Air traffic management is essentially deliberately creating a non-chaotic environment. There's certain things we can't control, various uncertainties. And I think we still face a challenge as to, do we want to continue to try and control the environment as much as possible to allow us to almost predefine? And there is that move towards a more strategic view of managing the trajectories. And I think it's very clear that this idea of trajectory management is a very powerful one in ATM, because not only does it continue to support the safety ideals that we have, it also is quite important in terms of addressing the efficiency, the fuel burn, all these kind of things. At the moment, when we look at concepts and approaches that put decision making at the level of the vehicle, it tends to be at the expense of that efficiency or that capacity, for example, which is often the ultimate constraint that we're living with in the traditional ATM system. How that evolves as I say, we move forward with the huge number of air vehicles. We have this test bed with the drones, and the approach will certainly be different. I think we'll take the best of that as we learn it and bring it into the ATM system. And there will be, I think, a role for decision making at the level of the vehicle, but probably still in the context of a strategic view about how ATM works as a whole, because we're going to continue to have these issues regarding environment, fuel burn, and capacity. So I think there's going to be a mixture of the two. I think today probably the trend in traditional ATM is towards that managing through that trajectory approach, but I think we'll learn from what we're going to do with drones and how they work and the intelligence at the level of the aircraft there, and that will feed into a further evolution of ATM as the next generation.
Thank you both. I have a question for both Oscar and Li Hao. So Oscar, I was thinking about your presentation and the future that you painted with the different kinds of vehicles and Elon Musk's philosophies about the point-to-point. What are the things that we need to be thinking about as a global aerospace community to really enable that vision? And I would pivot over to you, Li Hao, because obviously, as with any growth, there are legal issues to be considered, and I'm mindful of the challenges already between trying to align the aviation and space law and potentially maritime law. So maybe both of you could offer some thoughts on how do we get there? What's the roadmap?
Thank you, Lee. I appreciate. I think we should be thinking about trade and commerce. I think the technology, basic or applied, and development is very exciting, very interesting, and some of the concepts we are looking at happen in a laboratory environment, which is exciting. New technologies, materials, propulsion, you name it. But I think what we need to be thinking about is when any of those technologies start finding friction or traction with markets, markets start reacting to them. And that's why I showed you a couple of models of high-speed transportation that even though they are not yet in space, they are getting close, but the markets have paid for them, have bought the vehicles and have invested in them. So I think we should be paying very close attention to what things could be, but get grounded into the reality of how markets are reacting. ICAO was formed in 1944, 40 years after the first commercial flight took place in Florida in 1904. We look back and you see that flight from Tampa to St. Petersburg with one passenger on board, first fare paid ever. You could develop the events until ICAO is formed. So I think we have to pay attention to the market demand, and those market and trade pushes will get countries to talk to each other about trade and transportation and commerce. I'm a big believer that commerce will be the driver of the scalability of our industry.
Well, I think there are 4 points I would like to point it out. First, that is keep a reasonable or acceptable level of safety. This is bottom line. And as I have pointed out, this have to be decided by the community. It is not set at the quantitative standard at the beginning. Secondly, since all these new operations are quite innovative, to meet the innovative operation, we have to establish smart regulation at both domestic and international level. Third, I would like to say that how to make this happen. We need to not only learning by doing, but also education and communication with each other. We need to have the regulators, the ANSP, the industry, and also the public. The third parties, they also have their concern. Fourth, we have to share the same vision that the regulation and also the innovation, round by round of balance of interest is seek for another round of balance to seek for, as I have pointed out in my presentation, that is another round of balance which could achieve the development, the good order, and also human dignity, because the innovation of operation is seeking to have a better life and better society.
Thank you very much. So now we have a final surprise for those that have hung in with us this afternoon. I'd like to ask my colleague Yuri to come on up on the stage, please.
Sorry, if it's okay with everyone, I'll do it from here because I have to run the computer. So, thank you very much to the panelists. In closing this part of the event, which is on innovation and emerging, we've been working with a local futurist, Charles Bombardier, and he's a fellow who does industrial designs for future concepts of all modes of transport. And he also makes that available in the open, well, he opens it up to anybody who wants to work with him on these. Some of you may have heard him. He's been featured on CNN, and he's also won a World Innovation Award. So unfortunately, he wasn't able to be here with us today, but I'm going to run 2 videos that he sent me to close this, this part of GANIS. And I hope you enjoy the videos as much as you've enjoyed all the discussions we've had. So just give me 1 second to run this.
My name is Charles Bombardier, and I'm the founder of Imagine Active. I'm an engineer and also an inventor. I've been passionate about vehicle design since my whole life. When I was really young, my father used to take me on snowmobile rides and also flying with his aircraft and all types of vehicles. So Imagine Active, what is it? It's a hub. It's a place where people meet and they share their ideas openly about the future of transportation. So you could have a scientist that works at NASA working with an inventor in a field of Nebraska, and then with a student that lives in Hawaii, and all these people are sharing their ideas on one subject or one concept. What I'm doing at the center of all this is that I'm managing these people and I'm trying to help them build a vision. It all starts with an idea. You have this idea or you have this problem and you want to solve it. And you think about it and then you start brainstorming. When you're ready, you contact the designer and you tell him about your idea. You try to work with him how to make it happen. So he has to make some sketches and then it's a back and forth relation with the designer. So at this point you really start to get excited because your idea is taking shape and you can see your idea in a whole new drawing. and then you put on some coloration to it. You find a name, you try to find a name that suits your vehicle, and afterwards you put your vehicle in a background that fits with what it's supposed to do. And that background is very important. It needs to convey the essence of the concept. When all those steps are done, then you get into a more complicated part, which is describing the vehicle with an article. So you need to create an article, you need to explain how it works, what it's going to be used for, in which market it's going to be sold. This text is as much important as the design itself, because some people will only read the text and some people will only look at the visuals. If you look and read them together, you will have more impact. What really caught the attention of the public this year was a series of hypersonic aircraft we designed. It started with the Screamer concept, which was published in the CNN, Forbes, Robb Report. That led to another concept called the Antipode, which caught the attention of NASA. And then it led to the Paradoxal, which won a lot of awards. So all these aircraft, what do they have in common? They excite the public. The public wants to ride in them. And I think that's one of the most important things in life, to be able to dream about the future and get people excited about it, and then to build it. Imagine that it's 20 years ahead in the future. You're living in a condo, and that condo has a huge balcony. And that balcony is designed so that drones can land on it, and you can receive packages there, and you can also take a flying taxi, it brings you to the airport. Another option would be to take a train. You take the train to the airport. And while you're riding to the airport, your luggage is being scanned. Your ticket is being checked in. The airport knows you're coming in. Your immigration card is being scanned as well. So all the things you need to do at the airport can be done in the train. And you know what? You probably have some good ideas on your own too. You probably thought about drones, airplanes, aircraft. Imagine Active, it's an open idea factory. It's open to all of you. So don't hesitate. If you have an idea, contact me. And who knows? Maybe we'll work on a concept together.
Well, I hope you enjoyed it. Sorry for this last minute mic question.
Yeah. Oh, I'm sorry. Thank you, Yuri. So I think what Yuri was trying to say is hope you all enjoyed a quick glimpse of at least one person's vision of the future. I really would like to take this opportunity to thank this wonderful panel, and I'm only sorry we didn't have more time, because what that video spoke to me is about the future. A topic we never even talked to today was about how do we engage today's youth to get them excited about that future, to help us to build this future. At any rate, thank you all for your kind attention and participation today. I think I speak on behalf of the panel. If you have questions of any of us, feel free to find us during the course of the conference, and we'll do our level best to answer any questions that you have. And of course, the presentations will be made available as part of the conference proceedings. Thank you very much.